All right, welcome back, chat. Today we are looking at 3.4, and our focus today is going to be on exponential and logarithmic equations. Exponential and log equations, in case we wind up needing them. I'm going to put the properties that we talked about today on that quiz, and that we're going to keep seeing. I'm going to relist them here without their names. If I take the natural log of uv, how does this expand? Addition. Specifically, it becomes the sum of the natural logs, ln u plus ln v. Okay, that's a powerful one. What if I have instead a division in my argument? They subtract between the logs, so natural log of u minus the natural log of v. This one is less important. I don't want to, that's poor language. How about u to the power of, I'm going to do v because my u's and my n's look very similar. If I take v to the power of n, how does this change? What that n do? Moves up front. N times the natural log of v. Okay, those are the three big ones. Now, beyond this, we're going to have to do a little bit of evaluating from time to time as well. What's the relationship between a log and an exponential? They're inverses, which means they do what if you take the log of an exponential? You can call cancel. That's one place where I'm okay with it. I prefer the language of undo. So, to write this one, this shows up in a bunch of different ways. But I like this idea. If I have log base b of, let's say, b to the power of x, I have a logarithm base b and an exponential base. What's the base of the exponential within my argument? B, again, right? I have log base b and exponential base b. What did we just say that logs and exponentials do? Undo. We're left with just this. Okay, these four properties is pretty much all it takes to get into some pretty awesome things that were hard before. Other properties that I'm just going to put here, and this will actually be the start. So I'm going to have this last comment, and then we'll get our first section. Last little piece. If I claim, and I use natural log for like everything, right? It's easier than writing the word log, and that's the only reason. If I claim that a to the power of x is equal to a to the power of y, this is true if and only if what? X equals y. Nice. This is the exponential version of this property. This is the one-to-one property, or the injective property. Can you write this as a similar property with logs, though? The natural log of x equals the natural log of y. If and only if what's true? X equals y. It's the same property, just turned to logarithms. Now, because I'm lazy, and only because I'm lazy, did that change to ln. If we wanted it more formally, it'd be the log base a of x equals, like we could change the base, but this is the simplest to write. These ones are my injective or my one-to-one, which maybe you're not big Star Wars people, but one-to-one looks like a TIE fighter, and I'm never going to quit making that reference. Cool. This is like the entire toolbox, and now we're going to start our projects that are easy. So here we go. First one, we are going to be solving. How hardcore do we want it? Let's do some exponentials. And today is pretty much all examples. Solving exponential equations. Okay, when we're looking at this, when we talk about an exponential function, it's not just anything with an exponent. It has to have the variable up in the exponent. That's what makes it exponential. Whether it's an x, a t, doesn't matter. Some variable up in the exponent. That's all that we need. So we're going to start with an easy one, and we'll just work our way up. Example, and I just want to solve. So our first one, maybe we don't have to get real fancy. I want to solve, we will get kind of fancy, 9 to the x equals 27 to the x plus 1. I want to know for which value of x this is true. Right off the bat, does my one-to-one property apply at this point? Abigail says no. Mickey, whether you thought no or not, how come I can't use that one-to-one or the injective property with this example right now? Base. They don't have the same base. The good news is we don't have to be too crazy fancy with this. Ken, do you know of another way to write 9 with a power or an exponent? Love it. I'm going to replace that 9 with 3 squared, and I'll put the x back on here in a second. I'm just going to make sure the colors match. I'll just do it right now before I forget. Riley, can you tell me another way to write 27? Love it so far. If you have 9 already, what do you multiply by to get to 27? So do you agree that's just 3 squared times 3 is 3 cubed? Yep, that's all I'm looking for. 3 cubed to what power still, though? X plus 1. All right, at this point, we have almost the same stuff. Like, we have the same base already. What happens when you raise a power to a power? Like 3 to the 2 to the x. They multiply. One last line, and I'll just switch to red consistently here. If I multiply 2 and x, everybody cool if I just get 3 to the 2x? Equals 3 to the, moment of truth, am I distributing, or am I just going to say 3 times x plus 1? Good call. 3x plus 3? The second that I have the same bases, what can I do? They just fall out, and I simply need to set the exponents equal, right? Okay. 2x equals 3x plus 3, I think. Solve it for x. Dot, dot, dot. -3. Can somebody second it? Cool. Did we have to use any fancy log props here? No. Do you remember doing these problems in previous section? Okay, we can make it a little bit harder if we just pick uglier numbers like fractions and stuff like that, but as long as you understand how negative exponents work, nothing crazy happens. Okay, this is the old way. We're going to do the new way, though. We're going to start again, though, with an easy one. I want to know, when is it true that 5 to the power of x is equal to, I don't know, 14? Seems reasonable. It feels like this problem is without an answer for us. I can estimate it. I know it's between 1 and 2 because 14 is between 5 to the 1, which is 5, and 5 to the 2, which is 25. I know my answer is between 1 and 2. But beyond that, it's tough, right? This is hard to solve because currently, where's my variable stuck? It's in the exponent, which means I have an exponential. Gosh, if only there were some possible way for us to undo an exponential. Oh my gosh, let's take the log. Now, here's the cool part, or the terrible part. It is natural to want to take log base. Any thoughts? 5 would be the natural choice because we typically think of log base 5 undoing exponential with base 5. Here's the cool thing. That fancy formula that allows us to change the base says we can really use whatever we want. I could write log base 5 or take the log base 5 of each side, but if only there were an easier to write, simpler logarithm that we deal with regularly. I'm going to take the natural log. Last little piece. Algebra says if you're manipulating something that's equal, if you do something to the left, also do the exact same thing where? To the right. And we're talking left and right of the equal sign. I will never be this wordy again. I don't expect you to. Let's take the log And I'm going to take the natural log, but we'll just say the log of each side. Algebra says I can do it. I'm not dividing by 0. I'm just introducing something. What that means is our next line then would look like this. I'm going to use the natural log. You can use a common log or log base. Who cares? I don't care what number you pick. Natural log is always the shortest. The natural log of the whole left equals the natural log of the right. And I'm just going to put those numbers in there. We had 5 to the power of x, and we had 14. Just the algebra aspect of it, are you okay with saying I've done the exact same thing? Big question. Does this say ln times 5 to the x? What's the word we use? Of. This is the natural log of 5 to the x. It's like a function, right? So I can't just divide by ln if I want. Here's where the big connection happens. I have 5 to a power inside of that thing. If only there were some power property of logarithms that allowed me to rewrite this. Holy cow, we can move that x to the front. I'm going to make a note of that, and we'll just stick with the red note, I suppose. Let's use the power property, which if you guys have it up there, that's x just moves right up front, which means on my next line, and I'm not going to have any more black writing, I get x times the natural log of 5 is equal to the natural log of 14. We have just expanded a little bit using that property. Any issues here? Or what questions do you have here? All right, last big thing. You're going to hear me say this about 1,000,000 times, and I lied. I'm going to write black right here. Natural log of 5. I can't just divide by ln. I can't just divide by 5 because that thing right there is just a number. It's a number. I don't know what it is. 2 something. I don't know. This is a number. I want to stress that importance. Instead of saying ln 5, do you agree that it's just x times a number? If I want to solve for x, but it's being multiplied by a number, how do you undo that? Louder? Divide. And what's the number that I'm going to divide both sides by? Let's divide both sides by this number. So here we go. Little note to say, divide both sides by that number, but I'm going to write the natural log of 5. Which again, the natural log of 5 is just a what? A number. Without ever having to touch my calculator and think about it, I obtain the following. X is equal to the natural log of 14 divided by the natural log of 5. We have a perfectly good and fine exact answer. If this doesn't sit right with you and you want to reach for your calculator, you're not going to give me an exact answer. You're going to give me a what sort of answer? Approximate. Do me a favor. I want to know what natural log of 14 over natural log of 5 is. And then I'm going to move my exact phrase here, and we'll see why here in a second. Two point something is my guess. No, 1 point something. I have no idea what the something is, though. 1.63? Okay. If you get anything other than 1.63, shout it out loud so I know right away. Did you get something different? Okay. Now, I moved where I had the exact answer written. We have an exact answer and approximate. The reason that I moved it is because this kind of looks like something to me. The first question on your test was about the what? Your quiz, I'm sorry. And we're going to... If I look at this side, what's the top piece? What's the top argument? 14, and the bottom argument? This from change of base, and I'm going to change color. It's entirely up to you if you want to write this. Using change of base, the bottom number is my base. It's a 5, and it's a 14. That's exactly what happened here. It's exactly the definition of it. We're working with these properties, but if I said rewrite this in log form, you could. And you would write it exactly like this. You would say equals x, and then if you typed it into your calculator, you would just change the base probably to this, and we get the same answer. Okay, if that doesn't click right away, that's okay. Let's do another one. And by let's, I mean I want you to do one. C. Cool. Oh, I love this one. Gosh, they're all so cool. I want 3 times 2 to the x. So we have 3 times 2 to the x. And I'm going to claim that this is 42. I want you to solve this using the method of your choice. I assume it's probably going to be using log properties to some degree, but I want you to solve this with whatever method you want. Talk it out. I'm going to pause it. This is likely the last thing we're doing today. I mentioned the method of your choice. If you didn't catch what I said a second ago, in algebra, typically when you're trying to solve an equation for a variable, your first goal is to isolate it in some fashion. I have it so that only things with x right now are on one side. This is not the only way to do this problem. This is the way that I view it, and it's easiest for me. Once we get here, I prefer to use log properties, but it is the exact same thing, analogous as just using the definition of a log. What is the base of this? 2, and 2 to some power equals 14, right? If we just change it to log, this reads log base 2 of 14. That's how you use a definition. In my mind, it makes more sense if I use the properties rather than just a definition. Could I take the natural log of both sides? Okay, I'm going to make you guys stay like 10 extra seconds. If I take the natural log of both sides, I get here. Everybody cool? What moves to the front on this left side? So I get x times the natural log of 2 equals the natural log of 14. And then one last little step. What do we divide both sides by? What ugly number? Natural log of 2. If you had elected to just rewrite this off the bat as the log form of it, which is just log base 2 of 14, and you type this into your calculator, you're going to use change of base, and you're just going to type in ln of the top number, 14, over ln2. Same answer, different technique. You guys have a wonderful weekend.
Guys, my brain is ringing. Oh my gosh. Where are you going?
Cool. I will see you all on Monday.